Good afternoon and welcome to this, the third in our 2021 webinar series delivered by Dr. Tim Sandle. These monthly webinars are covering different aspects of Annex 1 and hopefully they will help you prepare for when it goes live. Today's topic will cover the essential elements of contamination control strategy. But before we start, just a couple of housekeeping. If you have any technical issues, if you'd like to send a short message in the question box on the right-hand side of your screen, we will try to respond and get back to you to solve it. Please be aware, though, that we are working remotely, so there might be a slight delay, and there is only so much we can do from our side. During the webinar, I'd like to invite you to ask as many questions as you'd like using the question box also on the right hand side, and at the end of the webinar, time permitting, we'll try to answer as many of these as possible. Any we don't get round to today, we'll answer offline and share them with you along with a copy of the slides from today. So welcome to the webinar. For those of you that attended any of our webinar series last year or the first two webinars of this series, welcome back. Thank you for your continued support. But if you're tuning in for the first time, my name's Annette Russell and I'm the Sterile Manufacture Lead at RSSL. I work in the commercial team here at RSSL and I work directly with the Pharmaceutical Microbiology team to support our clients who are involved in both sterile and non-sterile manufacture. If you're interested in any of the services that RSSL can offer to support you and your team, please do get in touch with me via the contact details you can see on your slide. I'd like to take a few moments today to introduce you to one of the members of the pharmaceutical team, Reg Fernandes. Hi, Reg.
Hi, Annette.
So Reg is the team leader and laboratory manager of the microbiology team here at RSSL, and he's worked here for 2.5 years. That's right, isn't it?
Yeah, that's correct, Annette. Yeah.
So Reg, can you give us a brief overview of what your role in the microbiology team at RSSL is?
Yeah, sure, of course. So pharmaceutical microbiology, we have a team of about 15 people, so it's just managing and looking after them on a daily basis and planning our workload to ensure we meet the expectations of our clients and their deadlines. Typically work to resolve any technical issues that both the team and our clients have.
So what does a normal day look like for you at RSSL?
No 2 days are the same, but typically for me, it's reviewing results, releasing CVAs, writing or approving reports, and of course keeping on top of my quality actions.
And that's because we're very GMP driven, isn't it?
Yeah, absolutely.
Yeah. So what would you say is the most popular service that the microbiology team are asked for?
Oh, this is a tough one. I'd probably highlight our Sterility service, which launched last May, which has seen a really good uptake, and probably as well our multi-TOF identification service, which launched at the start of this year.
Okay, excellent. And so if we look into the future, what are you most excited about for RSSL and the microbiology team?
I think for RSSL and for microbiology as a whole, it's exploring new potential technologies. At the minute, trying to look at automation and feasibility within a micro lab. So at the moment, right now, looking at whether automated endotoxin analysis or automated plate counting is a possibility. So I'd just say watch this space.
Okay, excellent. And finally, let's get to know the real Reg. So what do you do in your downtime when you're not looking after the team and our clients?
I guess it's not really a downtime activity, but pre-COVID I did enjoy traveling. I look forward to a time where I can get out to Las Vegas again, as I do like a little flutter.
I enjoy that as well. So thanks for your time, Reg. And I know you're off to have your COVID vaccine, so good luck with that.
Yeah, cheers. Thank you so much, and enjoy.
So as I mentioned, we can support your Annex 1 requirements here at RSSL, and I work with Reg and his team quite closely to do that. How we can help is we can help with environmental monitoring and risk assessment. This could be with hands-on as supplying and laying out the plates for you, or just performing the analysis with you sending in the plates. We can also, as Reg mentioned, identify organisms that you may find using our new MALDI-TOF. We can help with cleaning validation. Again, this could be a complete offering of service or just sections of it, such as validating your disinfectants. We can also help with extractables and leachables. Some of you will know Annex 1 talks a lot about single-use plastics, and you'll need to know your extractable and leachable profile of these. And RSSL have a dedicated team to support clients with this activity. One of our core support areas is testing raw materials to pharmacopoeias, and from a pharma microbe point of view, this includes endotoxin and bioburden, and soon to have mycoplasma testing as well. We can also test the vials and stoppers that might be used in your aseptic fill finish lines. In fact, recently RSSL were interviewed by Rizwan Chowdhury, and if you go to RSSL's YouTube channel, you'll be able to find out more about that. We can help perform your container integrity elements as well. Again, a key requirement. And if you find particulates or pieces of items in your vials and what have you, we can help with our microscopy team, sorry, getting my tongue in a twist, who have several experts in forensic science, etc. And as Reg said, we have set up our sterility unit, and we're growing our sterility build capabilities, so we can help test any of your sterility, including med devices. And finally, we have a training team that can support your training needs. These can either be as online training, or when we're allowed, you can attend courses here at RSSL. They can come on site and do in-house courses for you as well that are bespoke to your own requirements. And one of these trainings, I'm pleased to say, is going to be run by Tim, who's going to be doing a course for us on the 12th of October on developing a pharmaceutical containment control strategy. So very pertinent to this webinar. Well, that's enough of me. I'd like to now introduce you to our speaker, Dr. Tim Sandle. I'm sure many of you have heard of Tim and subscribed to his many publications. Tim has over 25 years experience of microbiological research and biopharmaceutical processing. He's a member of several editorial boards and has written over 600 book chapters, peer-reviewed papers and technical articles relating to microbiology. Tim works for a pharmaceutical manufacturer in the UK and also finds time to be a visiting tutor at both the University of Manchester and UCL. So I'm going to hand you over to Tim now. Hi, Tim.
Okay, brilliant. Okay, well, thank you, everybody, and it's a great pleasure to be back with you. So the subject of today's webinar is the contamination control strategy, and this is obviously a fundamental part of the Annex 1 revision. So what I want to do in this webinar is to look at some of the key aspects that are required for such a strategy. Obviously, there won't be time to cover every single aspect, but what I want to do is have a look at some of the core fundamentals. So, which is why we've titled this the anatomy of a contamination control strategy. So a contamination control strategy is a system that consists of the integral elements of pharmaceutical product manufacturing. And it's something that's best achieved using quality risk management principles and supporting risk assessment. So for the previous webinar in this series, we looked at risk assessments, and then we're keeping those in mind as we decipher what is involved with the contamination control strategy itself. So we're going to have a look at microbial contamination, cleaning and disinfection, sterility assurance, facility design, a little bit about chemical and particulate contamination, and some other events that might lead to contamination events such as mix-ups, damage to primary or secondary packaging, distribution problems, and the like. So these are some of the aspects that could lead to contamination events occurring. So what is Annex 1 asking for? Well, Annex 1 is requiring a holistic contamination control strategy. So by that it means that everything is connected together, particularly where contamination can be transferred. So we need to link up raw materials going into a process, the cascade through grade DC to B clean rooms into grade A, all those kind of events, not just looking at things in isolation. And by strategy, it's requiring a document or perhaps a series of connected documents which are developed to reflect the site-wide approach for minimizing contamination events. So the greater document or documents would be covering things like design of the plant and process, utilities, materials control, the process for onboarding vendors and approving those, control of the outsourced activities, which includes sterilization, process validation. And with process validation, it's interesting that as an aside, FDA have just approved ICH Q12, and ICH Q12 is the new ICH quality document that actually looks at what variations you're allowed in terms of adjusting process parameters. To this, we can also add preventative maintenance and cleaning, disinfection, and so on. And the focus is going to be on contamination and cross-contamination, and this needs a degree of scientific understanding supported by technical procedures and appropriate controls. And then below that, there are some kind of more nuanced approaches of the contamination control strategy that would be included, and we won't have time to cover all of these, but it's just to give you a flavour of the depth that such a document needs to include. So we will have things like justifications for the maximum number of operators that are permitted in critical areas. We'd have to have sound risk evaluation and risk mitigation strategies for the transfer of materials into grade A and B areas. We need to have worked out what the isolator or RABS disinfection procedures are. Considerations for minimization of not just microbiological contamination, but extending that to pyrogens, and by pyrogens, that's not just necessarily endotoxin. Particulate contamination, that would be both visible and subvisible particles. A lot around controls of freeze drying, how the environmental monitoring program is developed and how that relates meaningfully to the contamination control strategy so that the environmental monitoring undertaken is with value. Also covering things like which microorganisms are to be identified and what is actually done with that data. Touched upon raw materials, but here we'll also have the microbial quality of starting materials, and even what we're going to be doing about those areas interfacing clean rooms, so controlled but not classified areas such as staff changing, access corridors, perhaps wash bays, depending upon the layout of the facility. Okay, so how to establish and when to establish a strategy? Well, for existing facilities, there's an assumption now from European regulators that there should be at least a proto strategy, because they would argue that the first draft of Annex 1 was issued in 2017, and the purpose of that was to signal to people what they need to begin to prepare for. So we're in almost reaching 4 years of that. And so if you do have something started, then there might be parts of this webinar you can benchmark against. And if you haven't started yet, hopefully this will give you something to consider. For new facilities, then as early as possible, and again the indication within the regulations is that you're really considering this as part of the design process. Obviously you'll develop it and revise it as things go on, but you're having that approach to contamination control very early in the process. And there's going to be times when you need to review. So you're going to get information from various monitoring and control systems, from change controls, deviations, and other forms of feedback, and also to adapt the strategy to advances in technology. So again, with many of these things, and it was the same point I made with the risk assessment webinar last month, is that all of these things need to be living, breathing documents. So we do need to continuously revise these things as things change. We're not creating these things for the sake of creating them and putting them on the shelves to gather dust. Not that we have dust in our clean rooms, I'm talking about the offices. Okay, so the elements of the strategy is that, just to go back to the point I said at the beginning, that everything should be connected. That we should also make sure that the contamination control strategy relates to the manufacturing control strategy. So we are acknowledging any variations to do with different types of product and the differences in processes and the relative risks there. And also to the quality control strategy. So we need to have an understanding about what critical quality attributes are being collected through the process and how we can relate those to the contamination control strategy. And within that broad umbrella, we would also have environmental monitoring as well. And we also need to capture the elements of cross-contamination. So that would extend to cleaning and storage and things like wet equipment and avoiding the recontamination of clean equipment with dirty equipment, for example. In terms of sources of contamination, we can present these as perhaps shown on the slide as it is now, and perhaps even break that down further into 4 generic groups. And these groups can be considered as air, water, surfaces in general, which could be manufacturing equipment, consumables transferred in, working height surfaces and so on, and then people, which is the most significant source of contamination. And I think we've discussed before that literature suggests that people are accounting for around 70% of contamination within clean rooms, which is why I've given that a different color on the screen. The other thing to bear in mind is that we shouldn't really be considering these contamination sources always in isolation, because contamination often occurs in combinations. So for example, if you take a clean room, contamination could potentially arise from air, people, and from equipment during the same work session, maybe in different proportions, but it could be from the same contamination event. We may have contamination in the air that contaminates people. The people then touch a piece of equipment, for example. So what we do now is have a look at some of these major contamination sources and briefly consider what the strategy can help inform us in relation to control. So the contamination risk from air within clean rooms is overcome through air filtering, and we can measure the effectiveness of that through different standards for different grades of air filter. So there's a European standard, EN 1822, and an ISO standard for HEPA filtration. And this gives us an indication of the ability of those filters to capture different levels and sizes of airborne particles. But we would need to enhance in the contamination control strategy things like sealants. We would need to put in there quite importantly, but sometimes overlooked, are things like torque settings. So that is the way that the HEPA filter is secured within the filter housing. And we also need to consider things like airflow, room pressure design. So we need to make sure that we've got appropriate pressure cascade so that when the air from the cleanest room moves outwards into a room of a lower cleanliness level, this actually prevents contamination, and what kind of study we might want to do on that in order to demonstrate that. So just some examples around air that can be considered. With water, I think I've said before that water is a double-edged sword in that it is both a vector for contamination, so a way of spreading contamination through, say, aerosol droplets, or even people walking through puddles. And it's also a source of contamination for those organisms that are able to survive and to grow in the nutritively deprived conditions that are associated with most water, particularly the more hardy gram-negative organisms. So with water, one of the kind of key issues is controlling time, because the longer something stays wet, then the greater the chance there is for organisms to divide. And those of you familiar with the way that bacteria divide through binary fission is that it's by a multiplying effect. So as we start to go beyond an hour or 2 hours, then that risk is compounded. And then also, if we have gram negatives and they die, we also have endotoxin risks as well. With materials, the surfaces within the clean room can become contaminated through deposition, for example, from the air, or from direct contact. And there is some variation in the risk from microorganisms depositing onto surfaces because there are different physicochemical forces that can either attract or aid the removal of microorganisms from surfaces. So in considering the risk of surface contamination, it's sometimes likely that the microorganism may not remain in contact for a long period of time, or it might do. So we have to weigh up that risk as well. And aside from surfaces, there's also the risk from materials and equipment being transferred in to the clean room. So the transfer is probably the weakest point in many processes, and is one of the aspects that needs to be given the greatest attention, whether that's through airlocks or through transfer hatches, or even items going into CNC areas, as say being delivered to a warehouse. And I'll loop back to transfer when we talk about cleaning and disinfection in a second. But the other thing about transfer and the contamination risks is we can also express that in the kind of following straightforward equation, where A represents the microbial contamination on or in a source. So contamination is there. But what also matters is the ease of dispersion of that contamination, either into the air or transferring from, say, an operator's gloved hand to another surface or surface to surface contact. Then we need to account for how close this is to the critical area. And then what is our control method? So this could be flushing things with grade A air supply in a transfer hatch, or it could be the application of a detergent and a disinfectant. And this kind of approach also helps us to inform our environmental monitoring strategy as well, because it can help us to pinpoint those areas where we need to orientate monitoring. And as I said, what is the particular risk aspect is the act of transferring items between clean rooms, particularly clean rooms of different grades. So elements we can build into the contamination control strategy are things like having multiple wrapping, and often in most instances, triple wrapping is a good idea, and the philosophy of moving wrappings through different grades. The focus on disinfection, and Annex 1 here calls out sporicidal disinfection between different grades. But also we need to be mindful that we're not using items that will generate fibres, so we need to be sure that the wrapping or the quality of the wipes that are used are going to be not shedding those types of particles. We need to have a list of items that are permitted to go into clean rooms, and it's an approved list. We need to make sure that all airlocks and transfer hatches are interlocked, and ideally have an alarm system that alerts to when those interlocks are not working or where there's a pressure problem. And also ensuring that the times that they lock for is sufficient for the contact time of the disinfectant. So if we have a 5-minute contact time for a disinfectant, but we are opening our airlocks in 2 minutes, then we're not allowing that disinfectant time to adequately elapse. So people, so as we've established, people are a very significant source of contamination. And that's because all people carry huge abundances of microorganisms. And even the most thorough gowning procedure will not avoid completely the risk of microbial contamination. And also people represent a highly variable and unpredictable source, in that one individual may behave in a way that increases the contamination risk on one day, but not the next day, or two people will behave slightly differently. And again, it kind of just extending out the contamination control strategy philosophy. You know, there are now things to consider, not just with the overall gown and for going into aseptic areas, ensuring everything is fully covered. But we also need to be mindful of unprotected skin conditions. So if somebody has cuts, what's the degree of cut and what you put on that if you let someone go into a clean room? Other forms of health checks, avoiding all cosmetics, lotions and perfumes, and there's quite startling literature on the amount of particles that they would be generated. Having good mask control, again ensuring that the clothing does not generate fibres, because if they go into the product that becomes a visible particulate and thereby an impurity. So there's a number of aspects there that need to be weighed up. Just to recap on the holistic aspect that I was talking about. So holistic means that every aspect is interconnected, and the overall sense of control and the level of quality is only really explicable by reference to the entire system as a whole. Therefore, for contamination control strategy to be effective, there needs to be an approach that can assess seemingly isolated events and look at those as part of the big picture, and also one that allows us to put in place appropriate preventative actions. Also, to develop a suitable contamination control strategy, we need to have a good level of process knowledge. So we need this in order to completely understand the different hazards and risks. So we need to make sure that we are drawing in the necessary expertise, and we have people who have an understanding of how the plant and process works. Ideally, those are involved in original sort of quality by design aspects, and to fully understand, you know, what exactly is the equipment used, for example, how does that equipment work? How is that equipment repaired? Where is it repaired? How does it go back into the facility if it's repaired outside? When is it calibrated? When is a repair sufficient that the process validation parameters require review? Are we indeed using the best technologies available in order to reduce the likelihood of contamination events? So they're the kind of key questions that need to frame our way of understanding work activities, perceived risks, required resources, and even whether we have the right organisational culture to deliver a quality-based contamination control approach. Another element is with the control of utilities, and utilities need to be controlled and operated within their design parameters. So we need to have an understanding of what those design parameters are, and then whether the requalifications or recertifications are referenced back to those original design specifications, and whether we have appropriate operational systems in place to know that day to day we're within those design parameters. So this would apply to things like compressed gases, HVAC systems, and water systems. And once we have solid controls, then we are able to also draw upon monitoring data. So if we take a microbiological example, if we have our, say, water for injection system in control, and we have it as, say, a hot self-sanitizing system at 85 degrees, then we can move on to consider what are the appropriate sampling frequencies and at what times of the day, which becomes quite an important question for a 24-hour facility, should that water system be monitored. Contamination control and design issues also relate to the selecting of suitable grades of cleanroom, and with design parameters intended to minimize contamination. So this would include, if we're doing future changes to an existing facility or creating a new facility, then we need to understand what are the construction materials, and are they suitable? Are they compatible with the cleaning detergents and disinfectants that we're planning to use, for example? Is the layout suitable for minimizing contamination? Do we know what the expected process and material flows should be? Will this layout permit the orderly handling of materials and the flow of equipment? Is it able to avoid mix-ups? Are we going to avoid cross-contamination of chemical substances with the product? Are we going to avoid crossing over different types of manufactured products as well as microbial controls? So again, the strategy can help guide us in that direction. And as I said, we also need a detailed understanding of the plant and the process. And as we start to do any facility upgrades or modifications, then we need to make sure that quality by design includes the control of contamination. So if it's an engineering product, it's not just focusing on, say, reliability or capacity, that contamination elements are also built within that. And this may include things like trying to reduce the number of process steps if each step is deemed to be a risk, to introducing closed systems where possible, to bring in single-use disposable technologies, by designing processes that require fewer personnel to be actually inside the clean room, and having good process maps in place so that we can show what our material and people flows are, and that there's a logic to them. And with aseptic processing, then the use of barriers is important, because if we look back to operators, even well-gowned operators, as sources of particles and also of microorganisms, then we should, wherever possible, have the principle in place that there's a physical separation barrier between the process and the product and this highly contaminating source of people. So where we can instigate isolators or rapid access barrier systems, RABs, particularly for aseptic processing, then that is of great importance. But even elsewhere in the facility, of the more things we can enclose within clean vessels and pipeworks, then the better things are. We also need to find out where we can implement closed systems, such as single-use disposable sterile technology. And this would include things like aseptic connection devices. And we also need to be sure we can assess the integrity of closed systems as well. So while these technologies are very useful, we do need to make sure they are suitable and have been suitably assessed as well. So there should be a validation package that accompanies them. So we should know what happens in terms of leachables and extractables, and particularly extractables when product passes through. We need to make sure that they're robust enough to be sterilized by the selected sterilization method, be that say steam sterilization, irradiation, ethylene oxide, that they maintain their tensile strength over the course of time that they are to be used for, and that a microbial ingress test has also been performed, because what we don't want is a weakness where contamination could be transferred from the hands of the people handling them, for example. We also need to make cleaning and disinfection fundamental to the contamination control strategy. And both of these are equally important, and it's interesting that cleaning is given even greater prominence in Annex 1 in relation to disinfection. So cleaning as a distinction is the process of removing residues and what's commonly referred to as soil, that's the dirt, dust, protein, fingerprints, bits of skin, and so on from surfaces. And that's generally to the extent that they are visually clean. And a good detergent works well because it penetrates this soiling, reduces the surface tension, and allows it to disattach from the surface, and then allows it to be removed. Disinfection is about the inactivation or destruction of microorganisms, generally measured in terms of a log reduction. So we need to understand when we're going to clean, when we're going to disinfect, at what frequencies we would carry this out, and how that varies for different usages. And we also need to ensure that the disinfectants used have passed an efficacy test, particularly in relation to surfaces, and that we've evaluated the suitability of the cleaning and disinfection schedule against environmental monitoring data. So within Annex 1 and the CCS, it's notable that there's a lot more on cleaning and disinfection, and I said with the importance of cleaning being basically raised to the same level as disinfection. And the need to rotate between two different disinfectants remains important, but there's also the requirement to incorporate a sporicidal agent into regular use. There's also a requirement to be mindful of residues as well, and to understand whether any residues might interfere with the efficacy of the detergent or the next application of disinfectant. And also where we're using non-sterile disinfectants, we need to be ensured that these have a degree of bioburden control as well, so not full of spores, for example. And then with the disinfectant efficacy testing I spoke about, there is a very clear requirement to understand how disinfectants and different surfaces interact against a appropriate microbial panel. And this starts to come into the territory when what the disinfectant manufacturer can offer stops and what the facility needs to undertake itself begins. It is possible to matrix different surfaces together for the purposes of evaluation, but you need to have a scientific approach to that. So for example, if there's 2 or 3 grades of stainless steel, you may elect to do 1 grade of stainless steel. Which grade would you do? Would you do the rougher one or the smoother one? It's that kind of thing that needs to be built into that program through some form of risk assessment. And you also need to understand that aging surfaces, and particularly surfaces that become scratched or damaged, will not be as efficient as the shiny new cut-offs that the qualification might be done with. So there needs to be some kind of system that prompts surface replacement, or at least understands the risk of older surfaces. We also need, as part of contamination control strategy, effective physical monitoring systems. So this would include things like pressures, air flows or air change rates, and often in a lot of areas, temperature and humidity, and particularly in aseptic areas where we need to keep the operators comfortable, not only for the sake of the operators, but also to minimize the degree of perspiration, for instance. So we need to do regular checks of these measures, and ideally this would all be done continuously and in real time, so that the data can be trended and there are audible alarms in place. And that's also in keeping with the process analytical technology approach, which there's quite a bit of FDA literature on the PAT approach. We touched on environmental monitoring and how this needs to fundamentally relate to the contamination control strategy, because it's the final check of the suitability of controls. So we need to have built into this what our viable monitoring strategy is, what our non-viable or inert monitoring strategy is for particles, and also how we're going to develop media fills in relation to aseptic operations. So the scale of the media fill, the length of the media fill, when media fills take place, whether they're independent activities or they're bolted onto the end of filling activities. We need to know and get as much thinking done in advance about what environmental monitoring excursions might mean for risk to the process or product or to the overall facility, and have an understanding of how we're going to set levels and trend that as well. So we always need to get to a state of control, and then we bring in our monitoring. And a lot of the monitoring is going to be focused on identifying, assessing and reviewing those more residual risks that might be there. And we also need to have a risk-based approach to the locations for monitoring. We need to ensure that what we're doing is based on an understanding of the process and process flows. And for aseptic areas, we can also draw upon airflow visualization studies to look for areas of air stagnation or areas that are disrupted by the movement of operators or of equipment. Need to help us guide the types of monitoring, as I've already alluded to, and also where rapid microbiological methods might be of benefit as well. And also we need to then set appropriate frequencies and have a defined incubation strategy. So this brings in the interesting area, which unfortunately we don't have time to go into, but it's about whether we use 1 or 2 culture media. If we use 1 culture medium, what are we going to put that into dual temperature? If we're going to do dual temperature, what's that order of incubation, and so on. But they're examples of things that need to be drawn out. And we also need to recognize that environmental monitoring is limited, and that's why a greater emphasis needs to be placed onto environmental control. And the reason environmental monitoring is limited is because of the limited recoveries. So it's either based on sample sizes or areas that we can sample, or volumes that we can actually collect. And then to do with the abilities of the agar and the incubation conditions, and then the presence of organisms that are not readily recoverable, either permanently or temporarily. So this places a great deal more emphasis upon trend analysis. And unless we're doing aseptic processing and specific batch release, then a single measure is of little value. We need to look at the big picture, which is important. And we should also approach the environmental monitoring as something that's systematic and is an active program. So as changes occur to the facility, they should be captured through change controls, and we can then adjust and update the program accordingly. And we should make sure that we're doing representative areas following process flows, that we're capturing points of weakness to do with air, surfaces and people, which tallies back to the categories of risks that we looked at earlier. So just a very simple picture on the slide there of some imaginary process rooms, and we have the direction that products take in, the direction that materials are taking, directions that people are taking, and the direction that waste is taking. And each one of those presents a potential weakness that we need to consider. We also need to capture chemicals, because there's a remarkable number of chemicals that are used in most cleanroom manufacturing environments. And chemical contamination generally occurs when unwanted chemicals get accidentally added to the desired processing materials. And the amount that gets added is often a very small or trace amount. And under many circumstances, this might be of minimal importance. But due to the sensitive nature of many products, then trace amounts can also have significant bearing on efficacy, upon performance, or upon yield. So cleaning validation is of great importance, and the evaluation of that through TOC swabs or conductivity, microbial monitoring, as well, is of great importance. And it's also important that cleaning validation is using an appropriate either representative of the product or a good surrogate like riboflavin or something like that. And then it's also equally important that equipment is kept clean and dry and there's not cross-contamination. And I'm just throwing that in there that just to emphasize that often a contamination control strategy, because it's in Annex 1, is thought of as a microbial control strategy. It's more than that. It needs to be embracing of any form of contamination that could ultimately cause product adulteration. So similarly, we need to be mindful of particles as well. And this isn't just airborne particles, which might be traditionally part of the microbiological program, but also from things like gases as well. So we may have nitrogen, we may have compressed air, for example. So we need to be understanding about what we're filtering and how often we're testing that. And also other sources of particles as well as people. We might have flecks of dried processing chemicals. We can have poorly maintained facilities where perhaps paint is flaking off. We may have dust. We might have fragments of glass from when vials keep breaking. We may have issues from solvents as well, and from actual wrapping. So there's a whole host of things there we need to be mindful of. And the contamination control strategy also needs to consider the training of people. And there's an important emphasis placed within Annex 1 on people having the appropriate knowledge and understanding to do their jobs. And people going into clean rooms should understand hygiene, basic microbiology, sources of particles, sources of contamination, and an understanding of aseptic technique. And then beyond that, we should balance theoretical and practical knowledge and capture things like how to stand properly within a clean room when not engaged in an activity. About, for aseptic processing, a fundamental understanding that there's no such thing as a safe intervention, and the need to minimize interventions and treat them very, very carefully. And then the areas with the whole transfer, looping back to the transfer disinfection, and also the ability to gown correctly and to gown in a controlled manner. So we do need to educate people and not just train people. So not blindly following compliance, but understanding the quality that comes out through education. We need to make sure that we're maintaining our utilities correctly. All of these various things are fundamental to the surround and the space that we work in. Whether we have good raw material control, and anything we are purchasing externally like raw materials, single-use disposable technologies and so on are subject to appropriate audit. We need to understand how we are measuring process control and the different elements that feed into that. So where we are taking readings from, what can we automate, how we feed that into the life cycle approach, also how we've evaluated container closure integrity, and whether, say, with Mimic sending vials around the world to simulate worst case temperature and pressure conditions. How we onboard vendors, and if the vendors, say, providing something that's supposed to be sterile, like a garment or a piece of tubing, whether we have an understanding of that vendor's sterilization process and whether that forms part of the audit. And that also then ties to how we outsource, whether we outsource, and what criteria is put in place for understanding the risks around outsourcing. And I mentioned before about the need for evaluating process steps in terms of risk assessments. And the CCI stuff feeds into good controls around good distribution practice. And also process validation needs to feed in, because we need to understand what parameters we could adjust, not adjust, how do we measure drift, and how does that loop back to the original validation. And we also need to understand things like hold times and the impact upon the potential for, if there is a bioburden present, for microbial growth as well. So there's a number of important elements there as well. Okay, so in summary, contamination is one of the major challenges to the pharmaceutical industry, and we need to have a thorough understanding of sources of contamination and the ways we could control it. So it's unsurprising that Annex 1 requires a written strategy, and this is something that is not done as a one-off activity, but needs to be evolving. So what I've done in the time available is tap into some of the key contamination risks, seek to show the kind of key controlled elements, to emphasize that monitoring is important, but it's not there to cover up control weaknesses, and we need to continually keep looping back to the contamination control strategy. So back to Annette for questions.
Thanks, Tim. It's just thank you. Sorry about that. So yeah, we've had a few questions come in while we've been listening to you. Some of them are quite detailed, so I'll try and pick the easy ones for now and give you more time to answer the more complex ones. So I've had a question from Nilesh, and he said, when is it best to perform personal monitoring? Is it best at the end of filling or any time during filling?
Sorry, what type of monitoring, Annette?
Personnel
monitoring. Okay, so finger plates should be taken one according to events, so following manipulations, interventions, or any kind of main activities, and then also at kind of set intervals. But the exit soup plates can only be taken at the end of the operation, because they affect the integrity of the suit, or when personnel take breaks as well. So it's kind of a combined approach to form a big picture. It's like the exit suit is the overall certification, the finger plates are kind of like the real life, what's going on while the activity is happening.
Okay, and I've got a question from Eva about what is the frequency of gas monitoring when in routine. So I think it means in routine status.
Okay, I guess that means like compressed gases. So there, one depends on whether it's going through a sterile filter or not. The second thing is there is a series of ISO standards on compressed gases that have recommended frequencies. I think the norm for, say, an aseptic processing area is around every 6 months and or after a filter change, but in lower grade clean rooms then annual would be appropriate. And that would include viables, It would include particulates and then also moisture and any chemical residues as well.
So that sort of ties into the next question from Ravi. How can a contamination control strategy connect with other forms of contamination, such as chemical?
I think it needs to be all embracing, and often, you know, if you think of chemical as mostly associated with the act of cleaning, then if you're trying to remove chemical impurities, then often you're trying to remove microorganisms as well. And there's an argument that if you haven't fully removed the chemicals, one, you might be creating opportunities for microbial growth, or you might be creating opportunities for microbial attachment, or you might be masking the microorganisms from the cleaning treatment. So they very much need to go hand in hand. It's just then also the contamination strategy needs to extend to how we're going to avoid mix-ups, how we're going to avoid the risk of mixing chemicals together. So very much, I think they should come together as it's like one document.
Okay, I've got a question from Anne Len, who said, should there be separate gowning and degowning rooms into a Class C isolator room?
That's an interesting question. So in the two versions of Annex 1 that got released into the public domain, the first one, the 2017 version, had that very aspect in there, but the later one, the 2020 version, that had gone, and it was replaced with a kind of a looser reference to it's needed for aseptic going into B clean rooms, but consideration could be given. So it's very much left to the user. So that kind of means really, you know, what's the level of risk, what's the level of potential contamination. My personal view is I don't think it is necessary for grade C, but you kind of expected just to present that out as why you believe that to be a lower risk. And probably the way around that is to have a control on the maximum numbers of people who are permitted to be in a changing room at any one time.
Okay. And I've got a question from Samir about what elements of the containment control strategy from the draft Annex 1 apply to non-sterile product facilities, if any.
Well, yeah, I think you're kind of in a more pick and choose category, because it's quite interesting that when Annex 1 has gone through this revision process, it says that this is for sterile products. However, if you're on the business of non-sterile manufacturing, then there are lots of elements in this that can prove useful, but it's not mandatory, but there's interesting things in there. So you know, a risk-based, thoughtful approach to environmental monitoring, for example, would seem important. A risk-based approach to assessing raw material suppliers and the degree of testing and which microorganisms are appropriate to test for, a sound sampling plan for a water system. So there's quite a lot in there that you can kind of draw upon that can give you pointers without necessarily having to worry about covering everything in terms of an audit. So yeah, there's lots. If you're working in non-steriles, it's worth reading Annex 1 and jotting a few points down that you can then take back into the different environment.
Okay, well, time is up, I'm afraid. So thank you, Tim, and thank you for everybody out there. I hope you found it interesting, and we appreciate the questions you've asked. Those questions we didn't cover in the question and answer session, I'll forward on to Tim, and as I mentioned at the start, I'll circulate those along with the slides from today. Remember that this was the second in our 9 webinar series. Our next webinar will be on the 30th of June, and that will cover clean room design and certification. And don't forget what I mentioned at the beginning of the webinar, that if you're interested in Tim's course on developing a contamination control strategy, which is on the 12th of October, please do get in contact with me. My details are in front of you all now. If you have any questions or want any further information, feel free to drop me an email or give me a call. So on behalf of the sterile manufacturing team, I'd like to thank Tim for continuing to deliver such informative webinars for us. Thank you all for listening, and please do not hesitate to get in contact with me if you need any support. Thank you. Have a good day.
Thank you. Bye.
Bye.